times 10 to the power 6 Pascal. Okay. So what we have found now, right? What we have found now. So if I'm going to draw our 3D element, so X, this is our Z, and this is our Y. So on element A, okay, so this is our element A, right? We have found this distance. We have found this value. So we know that over here, our stress Z is equal to 29.852 times 10 to the 6 Pascal. Okay. So the next thing that we are going to consider is we're going to consider the shear stress due to Bx. Okay. So I'm going to get the image for shear stress due to Bx. This is Vy. I want to get Vx. Vx. Yeah, it's this one. Okay. Hey, the figure did not come. Apologize. My apologies. Now it should work. Okay. So that is our analysis. Okay, so I just need a diagram. We know that Vx is equal to 16 times 10 to the power 3. Okay, and we know that this is a wide flange analysis. Okay, sorry, the wide flange, I think I make a mistake down here. Wide flange analysis is not 2Q, okay, it's Q, right? Box beam, then it's 2Q. Right, so over here, we know that we need to consider this area over here, right? If you look at the rules, we're going to use the analysis starts from the what? The maximum distance from the what? From the centroid. Yes or no? Okay. So you look over here. So we know that we are going to use Vx. So the shear stress is equal to Vx over Iyy, right? Qy divided by T, right? So we already know that Vx is equal to 16 times 10 to the power 3, right? The thickness on its own is equal to, we have written the thickness earlier. The thickness is 11.8 times 10 to the power minus 3 meters. Okay, so that is your thickness. So Iyy, we also know, right? So Iyy is equal to, is equal to 9.03 times 10 to the power minus 6. So 9.03. Okay, so there's your Iyy. So from here, you can calculate your, you need to find your Qy. Okay, so it's equal to A y bar. Okay, which is I usually do width times depth multiplied by y bar. Okay, so because so our width is equal to 11.8 times 10 to the power minus 3. Our depth, we know the distance from here to here is 75, right? So that is 75 times 10 to the power minus 3. The y bar is BF. So BF is equal to what? BF is equal to 0.166. So 0.166 divided by 2, right? So this is 0.166 divided by 2. And this is the distance that you want. This is your y bar. So sorry, this is your x bar. Okay, I will undo. This is your x bar. Okay, so I do apologize. I should write this down as x bar. Right, so this will be equal to minus 0.075 divided by 2. Right, so this will be equal to 0.166 divided by 2 minus by 0.075 divided by 2 times by 75 power minus 3 times by 11.8 power minus 3 is equal to 40.20268. Okay, so 40.268 times 10 to power minus 6 meter cubed. So once you know this, you're done. Okay, so the shear stress is equal to 16 times 10 to the power 3 multiplied by 40.268 times 10 to the power minus 6. Then you divide by 9.03, and then you divide by a thickness of 11.8 times 10 to the power minus 3. Okay, so this will be equal to 16 power 3 times 40.268 power minus 6 divided by 9.03 power minus 6 divided by 11.8 power minus 3 is equal to 6.046, right? 6.04647 in fact. Okay, 47 times 10 to the power 6 Pascal. And note the direction, yeah? The direction is going towards the left, okay, because it's how the shear flow. Okay, so this is due to your Fx, okay? So next we have to do the shear force due to Vy. Okay, so this one we have, okay, it's directly over here. Okay, so we know that it's 25 times 10 to the power 3. So I'm going to take this entire diagram. Okay, so I'm going to paste here. Oh, okay, you know what? I'm going to use the next page. Okay. So from here, let me delete this. Okay, so from here, okay, right, there is your element A. So you need to know this area, right, and this is the perpendicular distance, y bar now. Okay, so again, the shear stress is equal to, now we know is Vy over Izz, right, Qz divided by thickness. Okay, so we know that Vy is equal to 25 times 10 to the power 3. All right, the Izz is equal to, I'm struggling no, not Izz, sorry. Yeah, I will stop in the next 5 minutes. Okay, give me, okay, Qx. Okay, so the Ixx is equal to Ixx 40.8 times 10 to the power minus 6. And the thickness correspond to 11.8. So this is meter, this is Newton, this is meter to power 4. So the first moment of area about the x-axis is equal to width times depth y bar. So the width, so this area again, so this is 0.075. Okay, so there's a width. The depth is 11.8 times 10 to the power minus 3. The y bar will be equal to, so you need to find the depth, 0.205. 0.205 divided by 2 minus by 11.8 times 10 to the power minus 3 divided by 2. Okay. Let me write this properly or not. It's very blurry for you. 11.8 times 10 to the power minus 3 divided by 2. So this is equal to 0.205 divided by 2 minus 11.8 power minus 3 divided by 2 times by 11.8 power minus 3 divided times by 0.075. So I get 85.491 times 10 to the power minus 6 meter cube. Let me do it again. 0.205 divided by 2 minus 11.8 power minus 3 divided by 2 times by 11.8 power minus 3 times by 0.075 is equal to 85.491. Okay, so now you can calculate your shear stress is equal to 25 times 10 to the power 3. Qx is equal to 85.491 times 10 to the power minus 6 divided by 40.8 times 10 to the power minus 6 and divided by the thickness 11.8 times 10 to the power minus 3. So this will be equal to 85.491 power minus 6 divided by 40.8 power minus 6 divided by 11.8 power minus 3 is equal to 4.439 times 10 to the power 6 Pascal. And watch the arrow. The arrow is now going towards the right because of the Q. Yes or no? So 25 power 3, 85.491 power minus 6 divided by 40.8 power minus 6 divided by 11.8 power minus 3 is, yep. Okay. So now coming back to the element. Okay. So you have two shear stresses in a contradicting direction or opposing direction, right? So I'll draw our element again. Okay. So I will copy, take this whole thing. Bear with me, okay? I'm almost done. I know today it went a bit overboard. Okay. Okay, so we know that for this case, you have 1 over here, and this is due to your Vy, and it's inducing a shear stress which is equal to 4.439 times 10 to the power 6. The other one is in the opposite direction. This is due to your Vx, and the shear is equal to, so we did the shear is equal to 6.047, right? It's in the opposite direction because of the design of the shear flow. Okay, so 6.047. So the outcome is this. Okay, so the outcome is, I think it's very obvious. Okay, you guys can see it. The outcome is this. Okay, so this is our element again. So again, it's still going to do the 29.852 times 10 to the power 6 Pascal. But the resulting shear stress is going to be in that direction because it's equal to what? 6.047 times 10 to the power 6 minus by 4.439 times 10 to the power 6. So this will be equal to 6.047 power 6 minus 4.439 power 6 is equal to 1.608 times 10 to the power 6 Pascal. Okay, so 6.047 power 6. Yep. Okay, so yeah, this is quite a long example, and I'm not done yet. Okay, we still have a bit more to go, but I'm going to stop here. It's late for you guys. Okay, in that case, the ginger, stay behind. Okay, the rest I'll see you guys on Thursday. Okay, then on Thursday I hope to discuss about your term test with you guys. Okay, and I want to make sure that you all can access the